Question 1. In the context of commissioning a new office building's HVAC system, Garcia notices inconsistent temperature zones despite the system passing initial pre-functional checklists. The BAS sensors show proper calibration, but occupant complaints persist. What should Garcia prioritize next to resolve the issue? A. Recalibrate all sensors and actuators regardless of initial results. B. Review and verify the sequence of operation within the BAS programming. C. Replace the variable air volume valve boxes to ensure mechanical integrity. D. Increase the airflow rates beyond design specifications to improve zone comfort. Answer. Correct answer. B. Explanation. The inconsistent zones despite proper sensor calibration suggest a controls or programming issue, not sensor hardware failure or mechanical defect. Reviewing the BAS sequence of operation is crucial because improper logic can cause zones to behave erratically. Simply recalibrating sensors A without evidence wastes time. Replacing valve boxes C is premature without confirming faults, increasing airflow. Disregards design balance and could cause other issues. The commissioning process emphasizes verifying control sequences to align performance with the owner's project requirements, OPA, and basis of design, BOD. Control sequencing errors are common root cause in commissioning failures. Question 2. Given the circumstances of a hospital chilled water system commissioning, Patel is reviewing pump performance data and notes. A high differential pressure but low flow rate. Which is the best immediate action to take? A. Assume a pump impeller is damaged and order replacement. B. Verify valve positions and check for closed or throttled valves in the piping system. C. Increase pump speed to compensate for low flow rate. D. Reset the BAS control sequences and run functional performance tests. Answer. Correct answer. A. Explanation. High differential pressure combined with low flow strongly indicates a mechanical failure such as impeller damage or blockage within the pump, while valve position verification B is important. A closed valve would typically cause both low flow and low pressure downstream, not high differential pressure across the pump. Increasing pump speed C without resolving mechanical issues risks damage and inefficiency. Resetting BAS D is unrelated to mechanical pump performance. Proper pump testing and troubleshooting during commissioning include assessing mechanical integrity before control system adjustments. Question 3. When considering the impact of air and vapor barriers in commissioning, a new commercial building envelope, Istaliu discovers condensation issues on interior surfaces. Which concept best explains the root cause? A. Vapor barriers installed on the warm side of insulation prevent moisture ingress. B. Thermal bridging is causing uneven heat transfer and localized condensation. C. The air barrier is too permeable, allowing uncontrolled airflow and moisture transport. D. Insufficient insulation thickness is causing surface temperatures to drop below dew point. Answer. Correct answer. C. Explanation. Condensation inside a building often results from uncontrolled air leakage carrying moisture. A permeable or compromised air barrier lets humid air pass into colder cavities where condensation occurs. Vapor barriers A help, but only if air barriers control bulk airflow. Thermal bridging B contributes, but is less dominant than air leakage in condensation formation. Insulation thickness D matters, but will not prevent moisture carried by airflow from condensing. The building science principle emphasizes that air barriers must effectively control airflow to reduce condensation risk. Question 4. To what extent does the commissioning plan influence project success during the construction phase? Mr. Rogers is assessing why some equipment installation issues persist despite clear plans. A. The commissioning plan solely documents testing procedures and does not affect installation quality. B. A detailed commissioning plan enables early detection of installation issues and coordination among trades. C. Installation issues are mostly due to contractor errors and are unrelated to the commissioning plan. D. The commissioning plan only impacts system startup, not the construction phase. Answer. Correct answer. A. Explanation. While a commissioning plan outlines testing and verification, it also serves as a critical communication and coordination tool during construction. It sets roles, responsibilities, and checkpoints that can prevent or quickly catch installation problems. Saying it solely documents testing A ignores its broader role in proactive issue resolution. Contractor errors C are common, but a robust plan helps mitigate them through oversight. claiming it only affects startup. D. Underestimates its influence during all project phases. Thus, the commissioning plan directly impacts construction quality and project success. Question 5. Based on the information from a BAS trend log, Smith observes fluctuating supply air temperature despite stable outside air temperature and set points. What is the most probable cause? A. Faulty temperature sensors are sending erratic signals to the BAS. B. The economizer control is cycling frequently due to poor calibration or configuration. C. The ductwork has leaks causing temperature fluctuations in the supply air. D. The air handler fan speed is manually overridden causing instability. Answer. Correct answer. C. Explanation. Supply air temperature fluctuation with stable inputs often results from airflow inconsistencies due to duct leakage or improper balancing. Faulty sensors A. would cause random uncorrelated spikes, not consistent fluctuations. Frequent economizer cycling B. would usually correlate with outdoor temperature changes, which are stable here. Manual fan override D. is less likely unless indicated by the data. Proper duct integrity and balancing are fundamental HVAC commissioning steps to maintain stable supply conditions. Question 6. From the perspective of risk assessment during HVAC commissioning, HRConquer must prioritize potential failure points that could severely affect occupant safety. Which system should receive the highest priority? A. The chilled water loop supplying the cooling coils. B. The fire smoke control system integrated with the BAS. C. The domestic hot water circulation pumps. D. The lighting control system within the building. Answer. Correct answer. B. Explanation. Fire smoke control directly affects life safety by managing smoke movement during emergencies, crucial for occupant evacuation and firefighting, while chilled water loops A and hot water pumps C affect comfort and operation. They pose less immediate risk to safety. Lighting controls D are secondary in emergencies compared to smoke control systems. Risk assessment prioritizes systems whose failure causes injury or fatalities. Commissioning must ensure safety-critical systems perform reliably. Question 7. As demonstrated by a recent commissioning report, Mr. Lewis finds discrepancies between the owner's project requirements OPA and basis of design BOD documents. What is the best course of action? A. Proceed with commissioning using the BOD since it is more detailed than the OPA. B. Update the OPA to reflect the current BOD and inform all stakeholders. C. Halt commissioning until the OPA and BOD are reconciled and agreed upon. D. Use the original design drawings as the authoritative reference instead. Answer. Correct answer. A. Explanation. The BOD translates the OPA into specific technical design decisions and is generally more detailed. Proceeding with commissioning based on the BOD allows verification against the design intent. Updating OPA B. or halting commissioning C. could delay the project unnecessarily. Design drawings D. might not reflect current design intent if revisions exist. Effective commissioning reconciles these documents but tests against the BOD to confirm the system meets the project goals. Question 8. When faced with inconsistent BAS alarm logs during the startup of a heating system is new and suspects a communication issue, which step should she take first? A. Replace all BAS controllers to eliminate hardware faults. B. Check wiring and network connections between controllers and sensors. C. Reset the BAS software and reboot the system. D. Ignore alarms temporarily and continue testing other equipment. Answer. Correct answer. C. Explanation. Resetting the BAS software and rebooting is a non-invasive first troubleshooting step that often resolves communication glitches. Replacing hardware without confirming faults wastes resources. Checking wiring B is necessary but usually follows a reboot to confirm persistent issues. Ignoring alarms D risks missing critical system faults. Proper BAS troubleshooting protocols prioritize simple fixes before hardware replacement or ignoring alarms. Question 9. The fundamental question is how to verify system integration between HVAC equipment and fire safety controls during commissioning. Mr. Morgan must decide the best approach. What should he do? A. Conduct independent tests on HVAC and fire systems separately to confirm individual functionality. B. Perform integrated functional performance tests simulating fire conditions and HVAC response. C. Review system schematics and rely on contractor certification for integration verification. D. Use BAS trend logs exclusively to confirm proper interaction between systems. Answer. Correct answer. A. Explanation. Though integrated testing, B, is ideal, it may not be safe or practical to simulate real fire conditions during commissioning. Independent tests confirm each system meets performance criteria before combined operation. Solely reviewing schematics and certifications, C, is insufficient without empirical testing. BAS trend logs, D, supplement but do not replace hands-on functional tests. Commissioning best practices emphasize thorough testing of individual systems first. Question 10. Throughout the course of commissioning, a variable refrigerant flow (VRF) system, Mr. O'Brien finds unusual fluctuations in compressor speed and frequent cycling. What is the most probable underlying cause? A. Incorrect refrigerant charge causing pressure imbalances. B. BAS software not supporting ERF system-specific control sequences. C. Inadequate sizing of the outdoor unit relative to building load. D. Faulty temperature sensors feeding incorrect data to the controller. Answer. Correct answer. D. Explanation. Faulty sensors often cause rapid cycling by providing erroneous input, prompting the controller to constantly adjust compressor speed. Incorrect refrigerant charge usually causes performance degradation but not rapid cycling alone. BAS software issues, B, manifest differently and are identified through programming reviews. Undersizing, C, causes inefficiency but not necessarily fluctuations. Accurate sensor data is critical for stay ERF operation and effective commissioning. Question 11. Considering the evidence from a chilled beam system commissioning, Thompson observes that certain zones experience overheating during peak hours despite proper BAS temperature control settings. What should she investigate first? A. Whether the chilled beam coils are properly sized to the cooling load of each zone. B. If the ventilation air dampers are modulating correctly according to the set points. C. The quality and tightness of insulation on chilled water piping serving the beams. D. The calibration of temperature sensors located in the affected zones. Answer. Correct answer. C. Explanation. Overheating during peak cooling hours often results from heat gain through improperly insulated chilled water pipes, which can raise supply water temperatures or cause thermal losses, reducing cooling effectiveness. While coil sizing and damper modulation B affect cooling, these are typically verified during design and startup. A sensor calibration D is important but less likely to cause consistent overheating. Proper insulation minimizes unwanted heat transfer, which is critical in chilled beam performance and energy efficiency during commissioning. Question 12. Under the assumption that a hydronic heating system is failing to maintain design temperature in a large auditorium, Mr. Wallace suspects flow imbalance. Which commissioning step should he perform first to confirm this? A. Measure differential pressure across each heating coil to identify restrictions or blockages. B. Increase pump speed to raise overall flow rate through the system. C. Replace thermostatic radiator valve suspected of malfunction. D. Flush the entire hydronic system to remove debris and sediment. Answer. Correct answer. A. Explanation. Measuring differential pressure across coils provides direct evidence of flow restrictions or imbalances causing poor heating performance, increasing pump speed. B. May exacerbate issues or waste energy without addressing root causes. Replacing valves. C. Is premature before confirming if valve failure exists. Flushing. D. Is good preventive maintenance but does not immediately diagnose imbalance. Differential pressure testing is standard commissioning procedure to ensure correct hydraulic balance and proper thermal delivery. Question 13. Given the circumstances that a building's HVAC system frequently trips safety devices, Dias reviews the functional performance test results and suspects electrical overload. What should be her immediate focus? A. Verify motor nameplate ratings against actual operating amperage under load. B. Reprogram BAS to reduce equipment runtime and cycling frequency. C. Inspect mechanical components for binding or friction causing excessive load. D. Check voltage supply stability to the affected equipment. Answer. Correct answer. B. Explanation. Frequent tripping often results from motor overheating due to excessive cycling or runtime beyond design parameters. Reprogramming BAS to optimize runtime and minimize unnecessary start-stops reduces electrical load spikes and overheating risk. Verifying motor ratings there is important but less immediate if cycling is the issue. Mechanical inspection C addresses physical causes, but may not explain tripping patterns. Checking voltage supply D is necessary, but tripping due to overload is primarily controlled by operational patterns managed via BAS. Question 14. As illustrated by a recent commissioning case, Mr. Ahmad finds that the economizer dampers in a rooftop unit do not respond as expected during testing. Which troubleshooting approach is most effective? A. Manually operate dampers to verify mechanical linkage and actuator functionality. B. Replace actuator motors without further diagnostics since they are most common failure points. C. Check the BAS programming logic for correct control sequences and set points. D. Clean damper blades to remove any dirt or debris restricting movement. Answer. Correct answer. D. Explanation. Dampers stuck or slow due to dirt and debris are a frequent cause of unresponsive economizer operation. Cleaning blades often restores movement and proper function. Manual operation A is useful but less effective if debris remains. Replacing actuators B without diagnostics is costly and may not solve the problem. BAS logic checks C are important but first confirm mechanical freedom. Preventive maintenance like cleaning is essential during commissioning to ensure proper airside control. Question 15. When analyzing the root cause of erratic temperature control in a variable refrigerant flow VRF system, Fernandez notices frequent short cycling of compressors. What should she examine first? A. The refrigerant charge levels in the system for compliance with manufacturer specs. B. The BAS integration and compatibility with ERF system-specific control protocols. C. The accuracy and placement of room temperature sensors. D. The adequacy of outdoor air ventilation rates. Answer. Correct answer. A. Explanation. Refrigerant charge directly affects system pressure and capacity. Incorrect charge leads to pressure fluctuations causing compressor short cycling to protect equipment. BAS integration. B. End sensor accuracy. C. Effect control but secondary to proper refrigerant charge. Ventilation rates. D. Influence indoor air quality but not compressor cycling. Commissioning standards emphasize verifying refrigerant charge early to avoid operational inefficiencies and equipment damage. Question 16. Within the framework of commissioning documentation, Istacata must ensure that pre-functional checklists PFCS are comprehensive. Which element is most critical to include? A. Verification of equipment installation completeness and compliance with manufacturer instructions. B. Functional testing results of equipment under dynamic operational conditions. C. Client satisfaction survey regarding system comfort levels. D. Final commissioning report summarizing test results and observations. Answer. Correct answer. A. Explanation. PFCS focus on static verification that equipment is installed correctly and per manufacturer and design specifications before dynamic testing. Functional testing B is part of the next commissioning phase FPTS. Client surveys C occur post-occupancy and are unrelated to PFC scope. The final report D compiles all findings but is not part of checklist content. Accurate PFCS ensure readiness for performance tests, reducing risks of failures during commissioning. Question 17. In light of recent developments in building automation protocols, is UN encounters an issue where some devices fail to communicate with the BAS. What is the most likely cause? A. Incorrect IP addressing or subnet configuration causing network conflicts. B. Mechanical failure in field devices requiring replacement. C. Incompatibility of devices due to differing voltage power supply. D. Faulty sensors providing erroneous data to the BAS. Answer. Correct answer. C. Explanation. Modern BAS devices depend on proper communication protocols, but must also be electrically compatible. Power supply mismatches cause device failures and communication loss. IP addressing issues A. Cause network problems, but do not prevent device power. Mechanical failure B. is possible but less common across multiple devices simultaneously. faulty sensors. D. Affect data accuracy but not device communication. Commissioning must verify electrical compatibility and communication settings for reliable BAS operation. Question 18. For the purpose of evaluating risk during system commissioning, Easterbrook identifies several potential hazards in mechanical rooms. Which risk deserves highest immediate mitigation priority? A. Accumulation of combustible refrigerant gases due to leaks. B. Noise levels exceeding occupational health guidelines. C. Improper lighting affecting maintenance visibility. D. Inefficient equipment placement causing operational delays. Answer. Correct answer. D. Explanation. Improper equipment placement causes operational inefficiencies but is not an immediate safety hazard. Noise. B. And lighting. C. Affect worker comfort but pose less urgent risks. Combustible refrigerant gas leaks. A. Present immediate fire and explosion hazards threatening life and property. Commissioning protocols prioritize addressing safety critical risks such as refrigerant leaks before operational or concerns to comply with ASHRAE and safety standards. Question 19. Across different scenarios of commissioning chilled water systems, Mr. Kim notices some pumps operate at lower than design flow rates. Which factor most likely causes this? A. Improperly sized pipe diameters increasing system pressure loss. B. Excessive pump speed leading to cavitation. C. Overcharged refrigerant in the chiller evaporator. D. Faulty BAS control logic reducing pump run time. Answer. Correct answer. A. Explanation. Incorrect pipe sizing causes excessive friction and pressure drop, reducing flow rates below design. Cavitation. B. Relates to pump damage but typically causes noise or failure, not just low flow. Refrigerant charge. C. Affects chiller performance but not pump flow. BAS logic faults. D. Might limit pump runtime but don't directly reduce flow rate when pumps run. Hydraulic balance and piping design. Critical to system performance and must be verified during commissioning. Question 20. Throughout the process of commissioning, a rooftop packaged unit is Jackson observes abnormal vibration levels on the supply fan motor. What is the best first action? A. Inspect and tighten all mounting hardware and fan blades for imbalance. B. Replace the motor bearings preemptively to avoid failure. C. Increase fan speed to stabilize operation and reduce vibration. D. Ignore the vibration temporarily and continue functional performance testing. Answer. Correct answer. B. Explanation. High vibration often indicates bearing wear or damage. Replacing bearings preemptively prevents catastrophic failure and downtime. Inspecting mounts. A. Is important but may not solve internal motor issues. Increasing fan speed. C. Can exacerbate vibration. Ignoring vibration. D. Risks equipment damage. Commissioning best practice prioritizes early detection and correction of mechanical faults to reliable operation and safety. Question 21. With respect to a commissioning scenario where Mr. Fernandez is evaluating the BAS trending data, he notices unexpected spikes in chilled water temperature correlating with building occupancy. What should be his primary investigation focus? A. Confirm if the chilled water temperature sensor is correctly located and insulated. B. Review building occupancy schedules for accuracy and coordination with BAS control sequences. C. Inspect the chilled water pump operation for intermittent failures. D. Examine the heat exchanger for fouling or blockage causing temperature fluctuations. Answer. Correct answer. B. Explanation. Unexpected temperature spikes correlating with occupancy suggest control sequences tied to occupancy schedules may be misaligned, causing the system to react improperly. Sensor location affects accuracy but does not usually cause occupancy-linked spikes. Pump failures. C. Cause flow issues but may not match occupancy patterns. Fouled heat exchangers. D. Cause steady degradation, not occupancy correlate fluctuations. Proper commissioning requires validating BAS sequences with actual occupancy patterns. Question 22. By evaluating the system startup of a gas-fired boiler is how it notes inconsistent flame stability and frequent shutdowns. Which commissioning action is most effective to troubleshoot this? A. Adjust the air-to-fuel ratio and verify burner combustion settings. B. Increase the boiler water temperature set point to stabilize operation. C. Replace the flame sensor as it is likely malfunctioning. D. Inspect the fuel supply pressure for adequate delivery. Answer. Correct answer. C. Explanation. Frequent shutdowns and flame instability often result from flame sensor failure, causing the controller to misread flame presence and shut down. As a safety measure, adjusting air-fuel ratio A and water temperature B affects efficiency but not flame presence detection. Fuel pressure issues D would cause flameouts but are less common if flame sensor is faulty. Flame sensor integrity is a critical safety, operational component in boiler commissioning. Question 23. From a practical standpoint, Estevans is commissioning a variable speed drive (VSD) control pump and notices the motor is overheating despite operating within rated current limits. What is the likely cause? A. Harmonics generated by the VSD causing excessive motor heating. B. The motor is undersized for the system load and needs replacement. C. Incorrect motor insulation class used for VSD applications. D. Pump impeller damage increasing mechanical load on the motor. Answer. Correct answer. A. Explanation. EDS generate harmonic frequencies that can cause additional heating in motors, especially if not properly mitigated. This is a common issue in commissioning variable speed equipment. Undersized motors, B, would draw high current, not normal current. Incorrect insulation, C, can cause motor failure but is less common and not immediately apparent in commissioning. Impeller damage, D, increases load but usually causes overcurrent conditions. Proper harmonic mitigation is essential. Question 24. Given the circumstances of an air handler unit commissioning, Patel observes that airflow measurements at discharge do not match design values. Which step should she take first? A. Check damper positions and actuator operation for proper airflow control. B. Increase fan speed above design to compensate for low airflow. C. Replace the supply fan as it is likely underperforming. D. Review duct static pressure setpoints and adjust accordingly. Answer. Correct answer. D. Explanation. Static pressure setpoints directly influence fan operation and airflow delivery. Improper setpoints cause airflow deviations from design. Checking damper positions A is important but secondary after verifying system pressure conditions. Increasing fan speed B without system balance can cause noise and energy waste. Replacing fans C without diagnostics wastes resources. Adjusting static pressure setpoints. Commissioning optimizes airflow to design. Question 25. In terms of commissioning a refrigeration system, Mr. Wang finds the system cycling on high-pressure limit switches prematurely. What is the best immediate action? A. Check for refrigerant overcharge and adjust if necessary. B. Clean or replace condenser coils to improve heat rejection. C. Verify compressor discharge valve operation for leakage. D. Adjust the high-pressure switch setpoint higher to avoid nuisance trips. Answer. Correct answer. A. Explanation. An overcharged refrigeration system raises condenser pressure, causing premature activation of high-pressure safety switches. Cleaning condenser coils B is good maintenance but not the most immediate cause if the system is overcharged. Discharge valve leakage C affects compressor efficiency but not high-pressure cycling directly. Adjusting switch setpoints D can compromise safety. Correct refrigerant chart. Critical to safe and efficient operation, emphasized during commissioning. Question 26. Throughout the course of commissioning, a heat recovery ventilator is Garcia notes improper airflow balance between supply and exhaust streams. What is the best first step to correct this? A. Adjust fan speeds and verify static pressure across each fan. B. Inspect and clean heat exchanger cores for blockages. C. Replace defective motor bearings causing reduced fan performance. D. Check duct leakage causing air loss in either supply or exhaust. Answer. Correct answer. C. Explanation. Motor bearing issues reduce fan performance and cause imbalance. Addressing mechanical faults first prevents inaccurate airflow measurements. Fan speed adjustment A follows once mechanical integrity is confirmed. Cleaning heat exchangers B impacts thermal recovery but less airflow balance. Duct leakage D affects system performance but is secondary to ensuring fans operate correctly. Commissioning protocols prior. Resolving mechanical faults before system tuning. Question 27. The primary reason for performing functional performance tests (FPTS) during commissioning is a. To verify that installed equipment operates as intended under dynamic conditions. B. To document completion of installation and pre-functional checklists. C. To train building operators on system operation and maintenance. D. To compare contractor work against design drawings. Answer. Correct answer. A. Explanation. FPTS simulate actual operating conditions to verify equipment and system performance per design intent and documentation. B. Training. C. In comparison to design. D. Are important commissioning tasks but secondary. FPTS confirm the functional integration of controls, mechanical components, and systems, which is critical for project success and occupant satisfaction. Without thorough FPTS, latent failures or inefficiencies may remain undetected. Question 20. In comparison with traditional pneumatic control systems, building automation systems, BAS provide which critical commissioning advantage? A. Enhanced data logging and diagnostic capabilities for system troubleshooting. B. Reduced installation cost and complexity. C. Guaranteed system reliability without manual intervention. D. Elimination of the need for functional performance testing. Answer. Correct answer. B. Explanation. BAS reduces installation complexity by using digital controls and communication protocols versus pneumatic tubing and components, lowering costs and maintenance. While BAS does enhance data logging and diagnostics, pneumatic systems can also be reliable. C. And FPTS remain essential. D. Commissioning benefits from BAS are primarily in system integration and remote troubleshooting, overall efficiency. Question 29. From a historical standpoint, what has been a major limitation of commissioning HVAC systems in existing buildings compared to new construction? A. Limited access to as-built drawings and documentation. B. Higher costs due to less need for documentation. C. Lower risk of system failures requiring fewer tests. D. Reduced importance of owner's project requirements. Answer. Correct answer. A. Explanation. Existing buildings often lack comprehensive or accurate as-built documentation, complicating commissioning. This leads to challenges in verifying systems and requires more investigative testing. Higher costs. B. Occur due to retrofitting, not less documentation. Risk. C. May be higher in existing systems. Owner's project requirements. D. Remain vital regardless of building age. Thorough documentation review is critical for successful retro-commissioning. Question 30. Taking into account the role of post-occupancy commissioning, Mr. Davis wants to ensure continued system performance. Which action best supports this goal? A. Scheduling seasonal functional performance tests to assess system operation under varying conditions. B. Providing final commissioning reports and closing documentation only. C. Training maintenance staff before occupancy but no follow-up. D. Performing one-time system audits immediately after occupancy. Answer. Correct answer. D. Explanation. One-time post-occupancy audits identify operational issues shortly after occupancy but are insufficient alone for long-term performance. Scheduling seasonal FPTSA provides ongoing validation across conditions. Providing reports. B. And staff training. C. Are necessary but not sufficient. Best practice encourages ongoing commissioning beyond initial occupancy to ensure system efficiency and comfort throughout building lifecycle.